present. I would like you very much to welcome back to the stage Glenn, and he's going to take a step into the future and the present of the Vision AI space. Please give it up for the founder and CEO of Ultralytics, Glenn Jocher. Yes.
All right, thank you, Jason. After this one, though, you got to give me a break. I think 2 in a row is the max I can do right now. Okay, so everybody, thank you for joining us again. We've got a really special announcement today. We've got something that's been in the works for the last few months here at Ultralytics. We've been working on the next generation of object detection models. But before I talk about that, let me take a step back. I always like to start from the beginning. So our journey here in computer vision really starts in the particle physics space, as I mentioned before. And the ultimate purpose there is really to expand knowledge, to understand the universe better and the really mysterious laws that govern us. So the fundamental particles, their interactions, and of course, try and lead to a better understanding of what we're all doing here. So when I wake up in the morning, I ask myself, like, why am I here? What is going on? And how did I come to be here? And I thought in the early days of Ultralytics that our anti-neutrino efforts might kind of yield a bit more information there. There's a set of fundamental particles, and what we know about the universe doesn't match up with what we see. So there's a disjoint there. There's something missing. There's information missing. And as I started getting more interested in machine learning, I realized that this might possibly be an avenue to answer some of those questions. And one of the things that I realized quickly in physics is that you begin to run into a roadblock of human knowledge. So when I started, I knew nothing. At my interview for the program, I went to the Wikipedia page for anti-neutrino like an hour before the interview. And I filled up on as much as I could. And then after I started, I had a bunch of physics professors to talk to. So really great guys at the University of Hawaii that are in astronomy. And these are very high quality scientists, so people that have been to Stockholm for not themselves Nobel Prizes, but for their colleagues. And I would pester them every day, I think to the point of annoyance. I'd knock on the door, I'd say, John, I got another question, I don't understand this. And for about 3 to 6 months, I think, I was getting a lot of good answers. And then after that, no more. And then, I kind of realized there's nobody left to ask. And it was a bit frustrating. And this is when I realized, so if we have all this knowledge in our heads, but everybody is sort of an island unto themselves. We don't share this other than speaking it, putting it on paper, and it's tremendously inefficient. The amount of information that comes out of your mouth is just a very small fraction of what's going on up in here. But LLMs and I think other computer vision models, as the hardware expands, they don't have this constraint. You can make these much larger, and importantly, the communication is very fast in these systems. And so this compares to a human brain where the larger you make it, the longer it takes information to get from one end to another. So this goes back to what I said at the beginning too, that information flows very slowly in the human brain. And if we just had a bigger brain, I don't think that would really lead to a much smarter person, because eventually there'd be huge delays in communication from one end of the brain to the other. But an LLM can get much bigger, and GPUs to communicate very quickly, especially with these Mellanox connectors and NVLinks and so on that have really proliferated in the space. So even if you have GPUs in one server, communicating with another server, the bandwidth that's available these days is very impressive. And of course, that's traveling at a fraction of light speed, not light speed because it has to go through media, but something close to it. And so this means that you could conceivably build something larger and larger that can scrape more and more knowledge, and that has access to pretty much all of human knowledge and might be able to deduct and reason at a level that a person can't. And so I think we're seeing a bit of that these days. We're seeing sort of a step in that direction. And I think the main question in the space is really whether such a model can extrapolate information that it's never seen before. So the training data, if you think of it as a space, whether it can step outside that. The creativity aspect. So this is really what got me interested. But of course, we're all very far away, and I thought my little piece of the puzzle could just be starting at the computer vision side, because I saw really close parallels with the particle physics. So in physics, we had these particles, you get a flash of light, and you reconstruct that. So you can imagine a bunch of, say, iPhone cameras sitting around a soccer ball full of water. And when a particle hits it, some flashes of light go off. You can measure the times, and you can use some fancy math to figure out what that was. Was it an electron? Was it a proton? What was the energy? Was it energetic? Was it really cold and weak? And where was it going? Where did it come from? And so the government in the US was interested in this more for the intelligence application. So they wanted to build detectors that would measure neutrinos, which happen to come from nuclear reactors. If you could develop these sorts of sensors, then you could really help the IAEA and non-proliferation efforts and so on. But the scientists, of course, everybody's got their own motivations, and the scientists really just wanted to learn more about the particles, and myself included. And so we worked on this very, very intensely for 5 years. It was kind of an all-consuming effort, and ultimately it led nowhere. The technology was too immature. We weren't able to detect the particles we wanted, and the data analysis was not accurate enough to be able to filter the particles from the background, which was much larger. And so it ultimately broke down, and the government shut the effort down, which was it was a mixed blessing. So this was the end of the particle physics days for Glenn, and the beginning of the machine learning days. And so I had a lot more free time, and this is when I really started to devote my effort into open source. So this is around 2020. So I'd never done open source before. I'd never used Python. And I'd never done computer vision, but I was very, very interested. And I think that made a bit of a difference, and also the community. Under the government, I was not able to open source my work. They really frown on that. But now that I was free to pursue, I think, my own passions, I really dove headfirst into the open source community. At first, I had a bit of a fear that people were just going to run off with whatever I did. And I think that came true a little bit. But also there was another aspect that I didn't foresee, which was the collaboration effort. And so when I first created AI models, they were terrible. And everybody showed up at my GitHub repositories and told me that. And that was very helpful, actually, because every time somebody pointed something that was wrong, that gave me something to do. Like I knew what to fix. And so this turned into like the best debugging I could ever hope for. Because obviously, as a single person, you can only test so many things. But as thousands of users, you can test a lot of things and arrive at a lot of edge cases and really perfect the product. So I worked for about a year working on not something brand new, but building off of what had come before. And so there's a famous phrase in science, if I see further than others, it's because I stand on the shoulders of giants. And I did the same thing. So I picked the best AI architecture I could find. And in 2019, this was YOLO V3 for computer vision. And this story is very interesting there. And it just got more interesting about a couple days ago. So a pair of academics at the University of Washington were working on computer vision algorithms. A few years before that, ResNet had gotten popular, and this is a big breakthrough, using convolution models to detect and classify images, mostly classify. And the breakthrough was that before that, we had fully connected networks, which were very expensive, and the weights were not convolutions. But of course, in an image and in lots of other domains, having a convolution kernel that can pass through these dimensions and scan for shapes that mirror what you're looking for is incredibly important. And if you can build that in a feature depth, then you can get low-level features and high-level features, and you can start to develop an understanding of the scene. And one of the main advantages and the big breakthrough that these two, Joseph Redmond and Ali Farhadi, had was that they managed to divide up a picture into tiles. So they turned into a chessboard, basically, and they just worked on each part of the chessboard. So they gave it a responsibility. They said, your piece is responsible for detecting things that are centered on your piece. And this gave the detection component of the algorithms a huge advantage, because no matter how bad that estimate was, it was still within that piece. And so this means that if you have a big picture now with an object detection based on YOLO, that you can't detect an object over here that isn't over here because the piece isn't that big. And so this was the main leap in the performance that they introduced, and also just passing through an image once. There were attempts at object detectors before that, and these were double passes. So it's essentially you do some work and then someone else reviews it. And this was you do all the work yourself and you just hand in the results. And this worked much better, twice as fast. And so it outcompeted the fastest detectors of the day, which were faster RCNN, and it became quite popular. It became so popular that Joseph got invited to a lot of speaking events. And he went to a TED Talk one day, he gave a speech, And a military officer approached him afterwards. He said, "This is amazing, and we'd love to put this in drones on the battlefield." And Joseph's, he had a bit of a reckoning because, until that day, he hadn't really realized what the potential uses might be. And he didn't like this, obviously. And he decided that the best way to prevent this would just be to stop working on it. And so he left the field, he got into teaching. And he had open sourced his work, though. And so other people continued from there, and myself included. His academic advisor, Ollie, he created a startup called Exnor, sold it to Apple, recently left. He's at the Allen Institute for Technology, and now he's working on LLMs. And they just released a few interesting models a couple days ago. Actually, they seem to be the most compelling open source alternatives, probably them and Mistral, I'd say, to the closed source models that you see out there, ChatGPT, Cloud, and so on. So this meant that there was nobody doing YOLO officially. The repo was there, it was public. It was really difficult to understand. It was written in C, and I did not know C, but I got to town working on it, reproducing it in something I was more familiar with, which was now Python, and just trying to make it easy to use for myself, because I'm kind of lazy and I like simple things. And so I did all this publicly, and people started using it. They started breaking it right away, and they said, "Glenn, this doesn't work, that doesn't work." And I kind of took it all personally, and every time somebody said something doesn't work, I would instantly start fixing it, because it turned into, I guess, a bit of an obsession of mine. And so I did this about 1,000 times within a year or two, until I ended up with something that was YOLO V3, but better. So I reproduced it, and I'd improved it. And I decided I need to launch something new, because it had substantially departed from the original models. It was outperforming them, it was doing different training augmentations, and so on. And so I called this YOLO V5. A colleague of mine, Alexei, who was in Moscow, released a similar version called YOLO V4, but working directly from Joseph Redmond's darknet repository in C. So this became immensely popular. I didn't realize this was going to happen. And towards the end of 2020, a lot of interest started coming in from startups and businesses, and I was able to start building a bit of a team. And I just happened to be here in Madrid. So my family's half Spanish, and I was just here hanging out in Madrid when we started monetizing YOLO. And so this was in the form of partnerships with other startups. So in the startup ecosystem and entrepreneurship, you typically have an idea, you have a product, and you want to get some traction. You want people to come to your product. And the startups were seeing a lot of traction on the YOLO V5 repo. And there's a lot of other startups in the space that do things like help you train models, help you log those, help you deploy them. And they all showed up at the door, like asking for partnerships. And this was great. So this helped the YOLO users onboard and offboard. So we call these on-ramps and off-ramps. Like, how do you arrive at YOLO? How do you leave? You leave with a trained model, and where are you gonna go with that? What are you gonna do? And so this was really the beginning, and this is the first point that we see here on the slide. And so once YOLO got popular, I think it started catching more and more attention, even from big companies. And so 2 years later, Meituan, which was a Chinese company, I think they're probably the world's largest delivery company. We just came back from China. We met with them in Beijing. We met with the YOLO V6 team. And they said there's 7 million delivery drivers working for them. I think hopefully not all full time, but they're also getting into drones. They're getting into robotic deliveries, and they developed their own version called YOLO V6 for this. And they're actually in production out there in the systems these days. I think they just passed 1 million drone deliveries, and they use YOLO V6 for obstacle avoidance on this. So the same year, YOLO V7 came out, and this was by the original authors that launched YOLO V4. And so what you're seeing here is that there's different companies playing the game. And so this is a very interesting space, because nobody really owns, I think, the rights to the technology. It's open source, and it's really, I think, the level of contribution that the individual or the organization puts into it, I think correlates with the level of attention and, I think, authenticity that's assigned to it. So these researchers were the original ones on YOLO V4, and they got a lot of traction also. And I started to realize, well, wait, I'd launched YOLO V5 2 years ago, and I was busy doing things like building integrations and partnerships and like hiring people, and I'd forgot to do R&D. And of course, so new models were coming out that were starting to outperform it. And this is a big problem. Since I'm very competitive, I said, okay, this is not going to work. And so I got the team together and we started looking at what had gone really well for V6, V7, and other architectures out there from other groups like Baidu with Paddle, Detection, and different research efforts by Meta with Detter, for example. And so we rolled all of this research, including our own internal R&D, into YOLO V8, and we launched this last year, at the beginning of last year, 2023. So this was launched as a brand new framework at the Ultralytics repo. So next year, YOLO V9 came out, and then just more recently, YOLO V10, which was a big advance by the team at Tsinghua University, which we just visited. And that's the story until today. So what is next year? That's the question. Okay. And what has happened this year with YOLO? So since we launched YOLO V8, what's gone on with it? What have people done with it? So we just crossed 100 billion usages of the models. This is a big number. It's kind of too big to understand. But this basically means every day people are using it about 500, 600 million times, which boils down to like many thousands of usages per second. But what does this mean? So this chart here, this is a usage over time. And since last year to this year, it just really exploded. And the usages are broken down here by what do people do with YOLO. What are these people all doing with these models? And so the number one thing that people do with them is prediction. So we see that training a model is something you have to do, obviously, but you only do that once. Once it's trained, you can go on and predict really in unlimited times with that. I wouldn't advise that. I'd advise you to keep retraining and improving it. But it's the most popular application is just to predict images or videos. And so we've got 97 billion of these events in the last 365 days, followed by tracking. So tracking is something that we've integrated directly into the Ultralytics package. It's very popular. And it's a requisite for things like people counting in areas. You don't count them twice. Trackers here, we don't create our own trackers. We integrate with third-party trackers. So we've got two of the best, BotSort and ByteTrack, and you can use those on any models, YOLO V8, V9, V10, and for different tasks, segmentation, detection, pose estimation, oriented bounding boxes. So after that, training models. So it looks like people have trained about 450 million YOLO V8 models in the last year. So more than 1 million per day, which is just astounding. Validation is something that you do when you want to measure the accuracy of the model. It looks like for every model that's trained, only 1% of those go on to be validated individually. So it seems like maybe people don't care too much about the accuracy or they're not concerned that much. And the last one is export. So export is incredibly important if you want to deploy in an efficient manner. So when you train a model, it's in a PyTorch format, and you want that a little bit more streamlined. And so you send that to a different format, like OpenVINO, for example, at Intel, or Onyx at Microsoft. So this is all great, and this is amazing, and it's really humbling to see all this traction. But of course, we can't stand still. You can never stand still, and especially not in a field like ML. You always need to keep moving, keep accelerating. And so these last few months, we've been hard at work creating the next generation of YOLO models that we are here to talk about today. These are called YOLO11, and they build upon all of the past successes that we've had and all of the past contributions from the community. So we have an amazing team here at Ultralytics, but we also have one of the most amazing open source communities in the world, really. We've had 800 people contribute directly to the models, to the technology. And of course, we've had hundreds of thousands of people using them and giving us feedback on what we can improve and what we can do better. So the timeline here for these models is that we're launching these on Monday. So you have a good weekend, and when you get to work on Monday, they'll be there. These are going to be at the Ultralytics repository, and we are actually launching something new this time also. So in the history of Ultralytics, we've only ever had open source models. But now we've also been getting requests from companies, from enterprises for something more tailored. And so now we have an enterprise component to YOLO Enterprise Models, and these are launching 1 month later. So we are launching a lot of models here, 30 models in total. I think this is the most models I've ever heard of a company launching at the same time. 25 of these are open source, and these are 5 different sizes for 5 different tasks. The tasks are image classification, object detection, instance segmentation, tracking, pose estimation, oriented bounding boxes. And on the enterprise side, we have models that are trained on a new proprietary Ultralytics data set of 1 million images. And these are commercially friendly and trained on backbones that should provide much more robust pre-trained models for refinement on individual applications. Okay, next slide. And how do these models perform? That's the million-dollar question, right? So they are the best models in the world at each of their respective sizes in terms of speed and accuracy. The models come in 5 sizes: nano, small, medium, large, and X for extra large. These apply to different spaces and different applications. So for edge devices, a nano model is probably what you'd go with. These are 2.9 million parameters, so incredibly small. And on the large models, these are about 40 million parameters. These outperform all previous generations of YOLO models by Ultralytics and by any other organization. And on the transformer side that we've had questions about, we do constantly experiment with transformer architectures, and we have ongoing R&D efforts there. We also have hybrid YOLO V8 models that we've created there. But what we see is that the speed, unfortunately, does not really allow us to integrate transformers into the official architectures, as the performance would be too slow versus CNN or fully CNN models, convolutional neural networks. So we have a few examples here of the models in action. And so at its core, YOLO is an object detector. We're spotting things in images. And what that thing is really depends on you. It depends on what you need, what your application is. If you love vehicles and you like looking at brands of vehicles, then you can do that with YOLO. If you're a doctor and you want to scan x-rays, you can do that also. If you have a coffee shop, you want to count how many people are coming by, you want to get demographics, things like how old they are and so on, so you can kind of really target a certain segment. YOLO will do that for you. Oriented bounding boxes here for satellite imagery, medical imagery, really rotationally invariant data sets. YOLO really excels at. And of course, human pose estimation for fitness applications, and also animal pose estimation, which might even be more popular. So we see a lot of agricultural applications. I think we have a speaker here that's going to discuss a success story in that space later. And so how do these models work? How do you use them? And so the great news here is that you use them exactly how you would use an existing Ultralytics YOLO model. You import the Ultralytics Python package, you call one of the new models, you train it identically to a YOLO V8 model, V9 model, or V10 model. And then you can export that to all the same formats, Onyx, TensorRT, OpenVINO, and many others. We try and make this as simple as possible here in code, but also with Hub, which is our SaaS tool. Since not everybody knows code, we want also a place where you can just click a few mouse buttons and get something done. That's Hub, and we also have an amazing talk by Sergio here. He's going to show that later. So I think that's it. I think I'll open the questions here if there's any time left, if I didn't go over too much.
First. Congratulations. Congratulations even. 1, 2, congratulations, Glenn. That was awesome. And the team at Ultralytics, absolutely fantastic. That is some huge news, and no pressure, but it's going to be ready on Monday, right?
Yes.
Amazing. Right. Wow. Okay, you're all invited to check it out from Monday. You've seen how easy it is to use, to integrate. It flows with your, previous experience of using YOLO, and it's got all those kind of new features and enterprise features as well. Do we have any questions? We got Hannah at the ready to throw a mic towards you, and anything you want to know about YOLO11, just bring it on. Okay. Do we have any questions coming in? Yes, we got a question. Right. Oh, Hannah, we got one down here. And yeah, okay, great. So you ready to catch? Woohoo. Oh, what an excellent throw. You've done that before. Yes. Could you introduce yourself? Thank you.
Yes, my name is Ivan, and I am a student in the University of Malaga. And I'm getting very interested in what YOLO can do. And my question is, what techniques are you using in this version to make more efficient real-time object detection and classification?
No, that's a great question. So it's really a combination, I think, of 3 different things, which are the augmentation techniques that you use when you are presenting images and labels to the model. So this is really an open-ended space, and there's different packages that we use, including augmentations and our own internal augmentations. And so we've optimized these, and we've improved our processes there. The second is loss functions. So there's different ways that you can compute losses on the three main things that you have for object detection, which are classification, detection, and regression on bounding boxes. And so we've gathered the best loss functions that we've seen in the space. We've read all the papers, and JinQ here has really done a lot of the architecture work there. And of course, the last one is on the architecture itself, like which modules have we changed. And we've optimized these models specifically for NVIDIA GPUs. In the past, we've tried to balance performance between CPU and GPU, and these models are really now more GPU optimized to take advantage of some of the latest hardware optimizations that NVIDIA has. So it's not, I think, a single answer, but I think it's, as Amama used to say, all of the above. When you, I think, combine multiple improvements, you get what we have here today.
Thank you.
Excellent question. Yes, you're going to have to throw that all the way to the person sitting next to you. Yeah, I'm afraid so. I don't make the rules. Yeah, could you introduce yourself? Thank you.
Yeah, my name is Rodrigo. I also study. Well, we both study computer science in Malaga, and we just came today to Madrid to hear the show. My question is because I've heard about, especially when it comes to NLPs, LLMs, that some companies are already implementing their infrastructure and not stopping, but using other lower level programming languages like Rust or C. Even you get this news, Elon Musk saying, the future of LLMs is in Rust. What is your point of view, at least when it comes to this computer vision that are already extremely efficient due to the smaller size? Is it really such a thing that necessary, or Python is already efficient enough, especially because of the usage of GPOs and all the libraries that are already extremely fast?
Yeah, that's a good question. And my own personal observation is Rust is extremely fast. We don't use it for LLMs, but we use it for code linting. We use a package called Rough that's built with Rust, and it works unbelievably fast. Unfortunately, the main architectures or the main frameworks that we use to deploy the models are not written in Rust. I'd like to see kind of more effort going towards there in the future, but then you also get into, I think, optimizations that are hardware specific. And so on the training side, we use PyTorch, we use NVIDIA GPUs, but then once you're done training, there's about a dozen different frameworks, and there's possibly like many more, kind of like a long tail that are developing that cater to different types of hardware. So you've got CPU optimizations like OpenVINO, Onyx. You've got GPU optimization, obviously, with TensorRT. And then you've got others like CoreML, TFLate that cater to mobile frameworks and so on. And so it's impossible to create just one thing that kind of solves everything. And so as you see, if you want to really optimize on one dimension like speed, you're going to sacrifice in others, like the number of endpoints that you can deploy to. Mm-hmm. So I think the deployment frameworks are probably already doing as much optimization as they can, and I'm glad to leave that in their hands, since we have our hands full here just working on the training and supporting all those deployment endpoints.
Thank you.
But yeah, I'm a big fan of Rust.
Fascinating question. And yes, we have, the mic is returning to its carrier, the carrier of the mic. That professional Olympic level basketball training came in very, very handy. We have a hand up there. Yes, the young man in the white shirt. If you wouldn't mind introducing yourself to the audience. Thank you.
Yes, my name is Julius Grasim. I study the master's degree at Complutense University here in Madrid. My question is related about the thing that you just said, that you optimize this YOLO11 version for the GPU. Do these optimizations carry out when exporting the models to other platforms?
No. So that's part of the problem. I think we may end up providing CPU optimized models also. But one of the design decisions that we had to make here, I think, was where to stop on the model count. So we've got quite a few models here now that we support quite a few tasks, different sizes, and so on. But I think this is something that as we grow a little bit larger and as we get more resources, that we should start to do, because once you're doing architecture R&D, you sort of arrive at a point where you need to decide what you're optimizing for. And if you're optimizing for a certain platform, it typically means that you're going to sacrifice performance on a different platform. So since GPU training and GPU deployment is one of the most common practices, we've started there. But I think CPUs, of course, vastly outnumber GPUs. We've heard this comment before, and I think it makes sense also to optimize on the CPU side. Not just on the architecture, but I think also, of course, in things like quantization and quantization of where you're training.
Right, fantastic. We've got time for one more real quick question here. I'll give you this mic.
So I was wondering if you are planning to look at the low code, no code way of integrating these models to kind of democratize access to computer vision for those people who don't have the technical background or the AI background. Is that something in the roadmap?
Yeah, absolutely.
Thanks, Glenn.
We love working on YOLO models and writing a lot of Python. But of course, I understand that not everybody knows Python and not everybody loves to do it, even if they do know it. And so we've put a lot of attention into YOLO, but we have a SaaS tool. It's called Hub, and it is slowly developing, and we are adding more and more features to it. And we want to bring these two closer together in the future, so you can train a YOLO model directly in Hub or to Hub from any other hardware that you have, and then use that as a sort of Google Drive for YOLO models, where you can have them in one place, deploy them to different endpoints, compare them, share them with your friends, make fun reports, and so on. So we're going to be, we're building up the Hub team right now, and I think we should have more and more exciting features there in the future. And we've actually got a talk also a little later exactly about that. So I suppose not just Hub Web 2, but also for our mobile app. We want to bring the whole family of applications here together.
Phenomenal. What a great note to wrap things up on. So as I say, watch this space. Much more exciting news to come. But I think we should give our very warmest congratulations and thanks to Glenn and the team for Ultralytics right now. Congratulations on YOLO11, and thank you for that brilliant, brilliant keynote.
Thanks so much, Oystein.
Thanks to you, man.